Hello and welcome to the Oxford MAT Livestream, coming to you on a week when I wasn't sure we were going to be live, or maybe I thought I was doing something different, but due to circumstances, this is what I'm doing. Sorry. So yeah, I can't spell. Thanks, chat. Yeah, I had a go. I knew as I committed in my heart that I can't spell, but I had a go anyway. The plan for today is to talk about some multiple choice questions. Now, I think I've talked about some of these before, but the plan is to just show you examples of MAT multiple choice questions. Expedited, that is my word of the day, I think. Good, but before we do that, let's try and settle in. I think I've pressed all the buttons I'm supposed to press. Briefly, just now forgot to press the one that actually makes me go live, so reckon we've got that now. Let's do the How Was Your Day poll. That's always nice, isn't it? There we go. Some people are having a nice day, which is good. Maybe that's a trigger for people to tell me that I've forgotten to go live or something. It's funny how much it looks like I'm live when I'm not live. A couple of times on these live streams, which we've been doing for a few years, we've had an awkward introduction bit at the start, which is not seen by anybody because I forgot to press the big blue button that makes it actually go out to the internet. But in the whole production software, it's all, nobody cares about this. This is not interesting. You're right, chat. Chat at the moment is just telling me that I can't spell and that everything's going terribly. That's in response. Now I was asked about a response. I said everything's going terribly, which is an overstatement. I'm not a big fan of emails and the current crisis or current matastrophe is requiring quite a lot of emails. I just checked the inbox and the MAT info address has got almost 1,000 emails over the last couple of. It was only set up a couple of weeks ago, so I don't know any other university inbox that has been set up and then immediately got 1,000 questions in the first 2 weeks. So in some sense, we're doing something right. Almost definitely a silly question. We're going to look at any questions that aren't on those additional papers. Because you've already been through this, an anonymous person on chat. No, sorry, I'm just going to talk about these 30 questions. I've only got a couple of hours, so before I get back to my 1,000 emails. I'm really sorry, by the way. If you've come to chat, if you've come in here because you're one of the 1,000 emails, we've responded to almost all of the 1,000 emails. But if you're waiting for a response, I'm really sorry that I'm doing this instead. And there's a question about MAT pre-interviews. I don't know what a pre-interview is. Is a pre-interview like an interview before an interview? Good. It's the second time I've heard the word pre-interview, but almost the first time I've heard the word pre-interview. First time watching live. You've watched every stream from the last 3 years. Welcome to the show, anonymous person. I'm not always this stressed. And bread in chat, because anonymous behind this poll. Can I quickly show you the bread? They got the offer. Nottingham Computer Science, 5 out of 5. For the day. Yep. Oh, any more announcements on the MAT before the interviews? What are we doing? People who have registered to do the additional MAT are currently in contact with us. There's more information to test centres going out tomorrow, Friday, and more information for remote invigilation candidates, people doing it at home tomorrow, Friday. There's a whole bunch of information going on. The priority for the department, kind of all hands on deck at the moment, is getting the additional MATs to happen. If you're expecting more announcements about shortlisting or interviews or other things you want to ask about the regular MAT, then the priority at the moment is getting thousands of people to do the MAT. Right, okay, let's have a look back. So the voting has happened. That thing's made it look like I'm no longer live. And let's put it on top. So let's turn off the poll. Oh no, my thing that said I wasn't live was just lying to me. Hi Anti-Anonymous at the top there. Let me stress every syllable of this. TCS are not involved in the additional MAT on Tuesday. And what else have I missed? Are all interview decisions still coming out this month? That's still the plan to do it to the time. Still the plan to do it to the timeline. At the moment, things are going well enough that I think, you know, we're doing everything so that we can get people to have some sort of a maths test score in time for all of the normal stuff. We don't want to have a knock-on effect on everything else. It's a bit laggy, yeah. Sorry, maybe. Hopefully we don't delay other stuff. And there's no confirmation email on the registration form. I want to say that that's for a complicated reason. It's for two reasons. One of them is a good reason, one of them is a bad reason. The good reason is we didn't collect your email address unless we needed it. I think that's important for GDPR or something. Secondly, because I didn't have time to look at all the settings on Microsoft Forms. There is a form which will let you download it. I don't know if that would make people happier if they print screened or took a download of the form after they'd done it. I don't think there's a setting for also ask people their email address and then send it, but don't store the email address because you don't need it for GDPR. It's been fun doing this in something that is a legal manner. And then there is a question. Here's a question. Will, come on, sort of chat's being a bit laggy for me today. So somebody wants to know is the mat on either it is Decaferius wants to know is the additional mat on paper or online as in the questions. So the format of the additional mat 23 is going to look like this. So here's the format. Grid on the front page, and then 10 questions, each on a separate page. Numbered A to J, lettered A to J, just like in question 1 on the mat. It's not exactly trying to replace question 1 on the mat. Let's not think of it like that, but it's formatted like question 1 on the mat to make it more familiar, and because it's the copy paste of the grid, right? So familiar grid on the front with the same rules as question 1 on the mat as multiple choice questions. This is the format. If you're taking this at home, you're going to get access to a PDF version of this, which you're welcome to print. If you're doing it in a test center, then your test center is going to be instructed to print the PDF for you slightly in advance, which is ironically the solution that physics used the day after math. You might have heard the physics aptitude test went for let's just print it the day after the mat. 2 and a bit weeks later, here we are. So for Oxford, we are going to look at both the first test and the second test in a way that we don't want people to be disadvantaged by taking the second test. I'm pretty clear in the draft shortlisting advice. Part of my job is to write shortlisting advice for tutors. The draft shortlisting advice I've got is at the moment says strong things like if they would have been shortlisted without the additional mat, they should still be shortlisted. I kind of think that's obvious. Yeah, so anxiety that you might have put the wrong thing. So I should have, given people a way to check the thing. Let's be clear. If you're doing it in a test center, you should talk to your test center and just turn up, and your test center will. Aside from all the process we've invented over the last couple of weeks, if you are doing it in a test center and you have access to the questions and the right amount of time, then that's the thing. It's happened. There we go. That's the important thing. If you want to do it at home, then it's really complicated. We need to send you some links and information and things. If that's what you want to do, then do the form. There's nothing to stop you doing the form twice, except it'll confuse me just a very tiny bit. Unsure if press send. Yeah. Duplicates are fine. I can survive duplicates. If anything, it confuses the only thing it confuses really is the tracker that says how many people have done the thing. If we get up to sort of 10,000 submissions on the form, then I think, well, who knows. Test center isn't doing the most supervised rest breaks. Fiona, we're doing, yes, so more info for people doing it at home, more info coming up tomorrow. We are doing rest breaks. That's a thing. Somebody emailed me about that. Don't know if it was you, but I have emailed someone back already to tell them if you normally get rest breaks and extra time, then we are doing that. Multiple choice. So Adam asked about cheating, and we're doing a system of remote invigilation. The best way to ensure that we prevent cheating is for me to not say too much about what we're doing. Like if you build a really good lock on a safe, what you should not do is post loads of descriptions of how it works. Good, right, okay. if you're doing it at home, you do not have to print the PDF, and you will get a very detailed email tomorrow on Friday telling you all of this sort of admin detail. The email is being workshopped a lot. Good. Good, okay, good. Right. Should we do some maths? Is that right? Kind of want to do some maths. I'm not sure I'm going to do all 30 questions. Maybe if I ever get a wiggle on, I might do all 30 questions. I think I want to give you the ideas for 30 questions. Maybe we don't calculate all of them. Is the difficulty the same? Don't ask me. I never know how difficult things are. It's appropriate. It's gone through a review process and we think it's fine. There is, yeah, look, now you're trying to hack my system by exploiting my ethics, right? You say, have you hacked people's cameras? That would be really unethical, right? Oh, yeah, you add mystery and then people ask further questions. And if there's one thing I don't need right now, it's 1,000 more questions. Just doing my job. Right, cool, let's talk about cubes. You ready? Maths time. Guys, 12 past 5, we're going to do some maths. Distance between opposite corners of a cube. So this one's a tricky visualization problem because you've got to work out how far away the corners of a cube are. In fact, you're told that's 2, and you want to find, I guess, the side length of the cube so that we can go and work out the volume or surface area. Reed's question, surface area. And that's a bit hard because we've got to work out what that distance is. Now, one way to do that is with like 3D coordinates to say that the corners of the cube in X, Y, Z space, the coordinates of the cube are here, here, and here, and to use some sort of Pythagoras thing. A different way is to draw in exactly this triangle, which goes along the base and up that side, and that has diagonal opposite that thing of exactly the length that we want. However you do it, it turns out to be the square root of 3 times a is 2. And then you want to rearrange that, find a, square it, multiply by 6 or whatever to find the surface area. Thank you. I thought it was yes, good. I have no idea what a good score is. Sorry. These papers have been used in previous years when just like a handful of people had COVID or something, so the average is not really something I want to put any weight on. You do worse on Mat A but great at Mat B. That sounds normal. MG, sorry, I'm expecting a lot of this. I'm expecting that a lot of people did very badly on Mat A because of all the tech disruption, but then doing great in Mat B, that would be great, please. If you do bad on Mat A due to disruption, but then great on Mat B without disruption, then you're demonstrating that the disruption was very large and that your raw ability without disruption is high. That is the best thing one can possibly hope for, I suppose. Well, I mean, the best thing would be no disruption, wouldn't it? Or no tests, just ice cream. Anyway, I got distracted. Good. Is that the real Richard Feynman? Oh, bless. Yeah, absolutely. Also, 3 blue, 1 brown voice here as well. Okay, we've got a numbers question next. I think I've got 4 minutes. That's not true. Do you need your MAT candidate number? Yes, please. If you don't know it, just put anything in the box and we will try and work it out. Please give us enough information to work out who you are. If you can find it on the TCS registration platform, or it's the number you wrote on the front of the test, if you can remember that, talk to your test centre, but registering, I mean, just give us enough that we know who you are. I've got a lot of lookup tables. A lot of people, it turns out, have put their email address down as their MAT registration ID. That's fine. Don't do the form again. We've got enough to work out who you are. It's going to be fine. Clip that, chat. Clip that, says Nav. Okay. Joking aside, what is this expression? It's got all these powers of x in it. And let's put it on screen. There it is. Oh yeah, this is up to 20. It's one of those questions with a year in, and I guess it's about fractions or powers, rules of powers. Half of these with the odd numbers are like this, and maybe we could bunch them together to be like 2/3 to the x, 4/5 to the x, 20/21 to the x, and then it's a bit more clear that if x is huge, all of these things are tiny, and the fact that there's lots of them multiplied together, that makes it smaller, right? very tiny. Good. Okay. I can't remember why very close to 2 is an option. Slightly larger than 1 is also. It would be so hard to prove this was slightly. Anyway, never mind. What's it if you go to 20 times 22 to the x? I think then it's huge again. Yeah, I think it's huge. Anyway, never mind. Not the question. See, we're speedrunning. This is the pace. This is the pace. There's not like. When I say this is the pace, I don't mean this is the pace that you should be doing questions at. I mean, this is the pace that I am going to do things at today. Rah, let's go. Henry, no, there is no confirmation email. Sorry about that. A, I don't understand Microsoft Forms well enough to give you the option to do that. B, was only collecting your email address if I needed it. Couldn't see a way to do email confirmations without having your email. Good, right, okay. Write the wrong number on every page of the answer booklet. That is fine. The writing your answer booklet on every page of your testing was in case, the sort of rare case that your test center drops it or something and has to put the pages back together, that they can do that. If they're all the same as each other, then your test center would be able to sort them out again. If you wrote your friend's M number on all the pages, and also your script got dropped, and also your friend's script got dropped at the same time, then we're getting confused. But at that point, hopefully the test center would say, there are loads of pages and I don't know whose is whose, right? The instruction could have been, please draw a unique like stick figure drawing on that's the same on every page, but you would have thought that was really weird. So it's write your own number on every page. Was it very close to 0? Yes, I think it was. What did I say? Yes, it was this one. It is very small, very small, very small, very small. Overall, multiplying, you say? Tiny. It's not just small, it's tiny. We've got some cosine stuff now. So I guess the question is to understand that first, what do you know about cosine? Well, cosine is 1/2 quite a lot, isn't it? It's 1/2 when, let me draw a triangle. Like, you're better at this than me, right? You're better at this than me. Oh yeah, it's like 60 degrees. Maybe I should put it degree. Oh, I don't really care. It says using degrees. Good. Okay. So maybe 240 over x squared plus 4 is equal to 60. But I guess it could be 300 instead, because there are other solutions here, or minus 60. There's an x in here. There's some possibilities, and I'm a little bit nervous that there could be lots more possibilities, because I know that cosine comes down again. So maybe I want to think about the range of values of this. That's a bit tough. Let's call this number on the right hand side d for degrees. So we're trying to solve 240x equals dx squared plus 4d, which I suppose we could write down some sort of discriminant for this quadratic. I've relaxed a bit now, I've spotted that it's just a quadratic. What would we need? We need something like, can I divide it by 60? Yeah, I'm going to call it 60d or something. Which do I d maybe 1 or 5 or minus 1 or something? That's a bit cheeky, isn't it? Just changing what my definition is so I can put a factor of 60 everywhere. And then divide by the factor of 60. Yeah, perfect. I'm going to lose so many factors here, aren't I? Is there a 4 there or no? There is a 4 there. Good, yes, okay. There is a 4 there. So then the discriminant is 16 minus 16d squared. Oh, I see. So if d is too large, positive or negative, then this will be negative, and we'll get no solutions. So we only need to consider d equals 1, I guess. So I have this like idea that d could be 1, or d could be 5, or d could be minus 1. I put in this factor of 60 so that I don't have to keep writing 60, 300 minus 60 or something like that. Anyway, I love this question in chat about the party, which I do want to do, but you know, yeah, anything bigger than that, right? I suppose d is minus 1. Does that work? Yeah, d is minus 1 as well. Or d is 0, but that doesn't seem to be allowed. Okay. I guess what I really mean here is that D should be between -1 and 1 in order for this discriminant to be positive. And for this discriminant to be positive, we should have some range like that. Okay. Next open day is, gosh, miles away in April, I think. April, May for the departmental ones. June, July for the big summer university ones. Anyway, so these are some quadratics. Once we've decided what the quadratics are, we need to solve for x. Doesn't seem too bad at all. Maybe you're remembering about factors of 60 along the way, but I think we're off and away now to try and solve for this. College reallocations work in that you get an email telling you that you've been reallocated from one college to another college. You don't need to do anything about it. You don't need to think about it. You should not lose sleep over it. It's a shuffling thing that we sometimes do. Test centre. For test centre number, what I hoped would happen is I hoped that people would talk to their test centre and get the 5-digit Oxford test centre number. We've issued all test centres that did the MAT with a special 5-digit test centre number. What people have actually done is a mixture of that versus just writing down the normal 5-digit test centre number, which I should have thought of as a thing. If you did that, don't panic. But if you did that because you just know the number and you haven't spoken to your school or college or test centre, then please talk to your school or college or test centre. They need to know that you're taking the test so that they know to have a room ready and print it and stuff. And they may be a bit worried about whether or not you're taking the test. So if you haven't spoken to them already, please speak to them. My plan was that you would only be able to fill that in if you'd spoken to them because you'd get the Oxford test number. I didn't realise that some people inherently know a 5-digit number for their school or college. Now that I think about it, I know the one from my old school. It's still in there, 14285. Right. I don't know what the difficulty of MAT 2 is. Why did I change the D to 60D? I regret that now because it is confusing. You're right, I should have just called it D for degrees on the right. I should have said solve 240x over x squared plus 4 equals D. And then I'd have realised that I had an equation like this, and a sensible thing to do would be to write D as 60e, or some other letter of the alphabet, right? Because that would put some factors of 60 over here that I could then divide by 60. What I did instead, and I'm sorry about this, is I realised I'd missed a trick, and I went back and pretended that I'd had the idea a line earlier, and that's very confusing. So I should have brought in a second letter of the alphabet, and then all this algebra should have the letter E in. But I was so close to having the right idea at the right time that I tried to fix it, and I don't think I got away with it, Josh. How do we get to know that we are registered for the extra MAT? If you did the registration form, good. If you can't remember that you did the registration form, please assume that you did the registration form. Test and closed, leaving in no information. Ask them to email us. Ask them to email us, but also hopefully they're getting information tomorrow. Hopefully that's an exaggeration and they have received some information from us. Facts about how to print a test following in the future. Nav has a different suggestion. Yeah, that actually probably captures what's going on with these numbers, which is 360n plus or minus 60, which then, I suppose, E would be the number 6n plus or minus 1. Lovely. Yeah, some schools and test centres didn't realise we wanted the Oxford one. So yeah, in some cases, people did talk to their school or test centre, got a 5-digit number, typed in, all fine. I'm fine with that. I naively hoped that this would be a way to make sure you were talking to your school or test centre. I hoped that naively. I realise now that people can just make up 5-digit numbers. Yeah. But Kai, you want to know about what counts as substantially affected. Essentially, if you think that the events of the first MAT 19th of October didn't show you at your best, for example, if you were locked out for an hour, or if you couldn't see the questions, or if you had 2 hours before the start or something, there are lots of people in that situation who were arranging a special extra test for. Up to you if you want to do it or not. If you don't, then we'll just look at your regular test score. If you have a special considerations form, we'll look at that as well, of course. But you don't have to do the additional test if you don't want to. I think we've got very close to marking order for first mat. The last question team, I think, are wrapping up. Yeah, you could note. So someone says in chat, note that. Note bene that over x plus 4. They've got some bounds on that, which is very clever. There was a rant in there. College exam officer. Morning the mat. Then we had disruption. Yeah, that is just a rant, but also none of that sounds like your fault. So I think you do get to rant about things. I hope you're now registered to do the additional mat if you had disruption. Waiting to hear whether Oxford thought we should or not. It is an Oxford idea. If we weren't sure about it being a good idea. Cool, you did the form. There we go. Yeah, okay. If we use the GCSE, oh yeah, it's fine. This is fine, by the way. If you put a random 5-digit number in, it means that I lose some sleep because I don't know whether you spoke to your test centre. So there's a chance that you didn't speak to your test centre and you're going to turn up on Tuesday morning and you haven't spoken to them and they didn't think you were doing the test. Because you might have just memorised this number. But that's fine. That's sort of fine. I'm losing sleep, but maybe you did talk to your test centre and you're cool. This was really a way for me to check that you'd spoken to your test centre and sleep well at night, but no. First mat didn't show up for 2 hours and 30 minutes. That is a long time. Is this, yeah, mat therapy. Is it mat therapy for you or for me? I'm not really sure. We're all here together. Right, cool, we solved a quadratic equation, but we didn't quite finish solving it, but I'm moving us on anyway. Oh, I hate this question. I'm really sorry. Therapy, eh? I cannot stand this question at all. And I wrote it. So, yeah, here's a polynomial that goes on forever. Don't ask. I mean, what the hell is going on there? It just keeps going. The coefficient of x to the n is the nth prime number. Does that even make sense? 1, 2, 3. Fine, yeah, okay. And then, so this is kind of just asking what the fifth prime number is, right? And I guess you're hoping that if you do 5 derivatives, then it's x to the 5 that you do. If you do 5 derivatives to that, then that'll be 5 times 4 times 3 times 2 times 1 times x to the 0. Which is lovely when you plug in x equals 0. Sort of. Let's ignore that for a minute. Yeah, it's just that. Just this constant 120. Which is lovely when you plug in x equals 0. And it's got a prefactor on it, which is the fifth prime number. Fifth prime times this. So we're going to work out the fifth prime number, which is not a very fun exercise, but here are some primes. Not 9. And then I guess we've got to do 120 times 11, which I think is E. It'd be fun if I got these wrong, wouldn't it? The plan was to automatically check all of them using technology and exciting lookup tables. I am no longer able to do that at all. It's my fault. JCQ numbers, they're called JCQ numbers. They're 5 digits. I should have remembered that everybody already has a 5-digit number for their test centre. Just a stupid mistake. The web form could just have said your Oxford test centre number and people would have paused a minute, but yeah, it's one of those things. We've done everything extraordinarily quickly. This is a really big test that we've built in or set up the admin for about 2 weeks. People like this one. Okay. Yeah, hopefully that's tired. What to know about 2023B in case you can't stay. Hi Miles. Hope you're alright. It's multiple choice. It's the same kind of idea as Math Question 1, same syllabus, same format. You know the drill. If you want to download some papers that are just like it with the same formatting and everything, then you can get 3 that we've done for previous years. COVID disruption, COVID and a typhoon. That was fun. Well, not fun, but yeah, anyway. You can get those on the Math website. I think you already know that. with some work solutions. I am trying to explain the questions or talk about the questions a little bit and make everyone feel happier about the mat, which is my main job at the moment. Should have made 11 an option. Oh, that's mean. That's mean. Is it F? What is F of 1 though, or F of 2? Yeah. So the reason I hate this is, does this actually converge at all? Like, does it make any sense? Does it have any derivatives? Does it exist on any region around here? I think it does, but the primes are quite. But there's loads of primes. I'm really not convinced that it actually defines a function for any interesting values. So it doesn't actually have any derivatives, and this is just formal operation. You do not get a confirmation email. Please do not stress. If you're doing it in a test center, please just talk to your test center. If you're doing it remotely, you'll get more details tomorrow on Friday. If you've chosen remote, invigilation, you did not even get asked for a 5-digit test center. It's very clever, isn't it? Or is it? Isn't it? Did it? I can't remember. I think it didn't ask you for a 5-digit test center number if you did it by remote. If you clicked remote invigilation. A lot of time. Tick and run box, change your answer. Yeah, just like question 1 on the mat, you can scribble it out and do somewhere else. This is going to be looked at by a human. If you're doing this in a test center, then they're going to either scan this page to send us a scan of your answers, or if you're doing it remotely, then there's a web form where you can transfer your answers to a simple web form, like the form Microsoft Forms web form you've already done to enter your options. And I have now learned how to do save a copy for your records so that you can rest well at night knowing that you did tick the options you meant to tick on the web form. Good. Okay, more details for remote invigilation people tomorrow. Is it weird that D was easier than C? Or is that just yet again me not really knowing? F of 0, 0. Yes. If you put don't know for the test center question, then it's fine so long as you're talking to your test center. So long as your test center knows. The point of that question was to check that you are in contact with the test center. Now if you lie and you just make up a number, or if you say, I don't know where I'm going to do it, then this is on you. So say, please go and find a test center to do it and talk to them and get a number. If you just don't know their number, then maybe talk to them, maybe ask them when you're talking to them. But I have to assume at this point, that if you're doing it in a test center, you've spoken to the test center. Miswrite it in a box, but the answer you circled is correct. So we're going to look at the boxes for this, and transferring it to the online form is the official record of your solutions. As you already made a B-test, we had some ideas. We were waiting to see if there was a typhoon or something, and then there was something much more disruptive than a typhoon. Am I going to do it in 10 minutes? I don't think so. I'm not planning to do a 10-minute video on this. Just tuned in, what are we doing? We're doing those extra papers from previous year's COVID disruption, the B papers, MAT 20B at the moment. We're just looking at questions. Real firm, I looked at this and said, it's kind of like x squared minus y squared equals 1, right? That would be y equals 1 minus x squared. Wait, hang on a minute. Don't at me. Plus or minus square root. Okay. And x squared minus 1 is like this. So there's only some bits where you can square root that. So that'd be a bit like D, but not so angular. And all that's really going on here is that it's the 20th root, of x to the 20 minus 1, which has got the same kind of properties. But it's not defined for some regions of x. Can you do this just by checking the origin? The origin is not included, so that's that one out. And then I think you can check some. If x is 0. If x is 0, there are no solutions. Oh yeah, now we're done. Because all of these have got solutions on the y-axis, and this one's the only one with no solutions on the y-axis. Yeah, Josh in chat, I've just read your message. Good. Okay. It is not made up of MAT A rejects. That's not fair. It's gone through a very speedy version, of the review process we do for the normal MAT. Speedy. because everything has to be speedy. Symmetry is a good suggestion as well. The B papers, you can find them on the same page, just scroll a little bit further down. They're not in the same table because they're not really the same thing, but they're if you scroll down a little bit further. Do you want a poll on a 10-minute video? Okay. You don't want this. I think you don't know. First person to vote, you're wrong. You do not want that. People really don't like them, I think. Yeah, so like extreme values over here. Great suggestion in chat. Does it tend to mod y equals mod x? And yes, you're correct. For large x and y, who cares about the 1? This is just like x to the 20, y to the 20, which is mod x equals mod y. And that's this bit of the graph where it starts to look like an x. Good observation that I think gets you the answer, because that's the only one that looks like an x on the big thing. Oh, so many votes. Rowan, why do you want this? Some people love this. Do you want a 15-second video of me just going, the answer's rule A this year? Yeah, I can do that. You don't want that though. You do not want that. You'll click on the video and you'll see it's like, you'll watch the 2 adverts that YouTube makes you watch, and then you'll see that the real video is the same length as an advert, and you'll think, oh no. And it's just some posh guy in the corner going, it was all B this year. You don't want that. You don't want that. Right. It's me in the corner, and a large bit, I shouldn't joke about this, it's kind of not funny, right? It's just me in the corner, and just on screen it just says B. And we just look at it for 3 seconds, and then I look at the camera, and then I say, the answer was B. And we do that for each question. The answer was, you don't want that. Is already too fast, I think, as it currently is. Right, okay, people are voting for a 10-minute video, so I've got to find 10 minutes of my life, I think. Otherwise, what is that? Squints. 36 people will be 90% upset. Good. Okay, I think I owe you more than that, actually. I think I owe you a proper solutions doc. I think we've made these in the past for the other B videos. And there's now quite a few people doing this one. Yeah, you'll probably get a proper thing. Gosh, I have to build so many things. Right, good. Okay. The thing is, if we could not discuss it online, the reason the solutions doc always goes up a bit later and the 10-minute video goes up the day before is, please could we not discuss it online? I think it'd be really easy to discuss it online, and there are at least some people who are A, doing it online, and B, have extra time, and it's not fair on them if other people go and talk about it online. Even if the people doing it remotely with extra time don't cheat, it's not fair on them to have some suggestion that they maybe cheated. So I think we've got to make it really clear, please do not discuss it online on the day of the test. If you do, nothing bad happens to you, I suppose. We always certainly can't tell who you are. But if, oh gosh, what have I pressed? Please we not discuss MAT 2023 beyond the day of the test. Oh yeah, I'm not putting the video up. I could disable the comments, but are we talking about the comments of? Yeah, once the video goes, if it's got solutions in, then maybe we might as well have comments, right? I'm saying we're not going to release solutions. Just aware it'd be really easy to just go straight to Twitter. What's it called? Go straight to X and post like, A. It's just not fair. You're going to be discussing the test on the take. Please could you not do it online if possible? Implications. So this is all about tracking different cases. There's different times when this polynomial, so this is, or not polynomial, but rational function or whatever these are called, this is negative in different regions. So depending on whether these 3 things are positive or negative, cases, and there are cases as well for whether this thing is positive or negative. I have written it backwards, but I'm going to fix it by putting the other one. Yes, good. Cases for whether that one's positive or negative. And really you just need to think, I suppose, about the number line. -1, 1, and -2 looks relevant as well. To say that this one is, say, this thing P, I'll write about P up here and write about Q down here. So this working? Can't really tell. Okay, so if p is very negative, less than -2, then all of these things are very negative. So this thing is negative. This is good, true, because it is negative. But then it switches to being false, then true, then false, right? Yeah, if x is huge, then positive. Okay. Whereas this one, x plus 1 over x minus 1, that's positive if, I guess, if x is huge, then this is positive. But it's not true there, and then it is true again in both of these cases. So, what does that mean about p implies q, or q implies p? Oh my goodness. Well, they're not equivalent. If p is true, then q is false. It's not correct. If q is true, then p is false. That's not correct. Q implies p. No, it doesn't. P implies q. No, it doesn't. Okay, I've eliminated all 5 options. Let's go again. Is p true at x equals -2? I don't know. I think no. Not a number, is it, on the left? Hi, Ethan. I was involved. I'm quite involved in all the things that are going on at the moment to do with this. Is my inequality the wrong way around? I multiplied the denominator by -1. Yeah, and then I failed to flip that. Thank you. Well, we're demonstrating. Also, half of it's below chat. Thank you. So my Q thing was exactly wrong. Perfect. Right, so this means that Q implies P, doesn't it? If you've got a tick for Q, then you get a tick for P. But P doesn't imply Q, because you can have a tick for P that doesn't go to a tick for Q, the same value of X. G'day. I find these very hard. X minus 1 or 1 minus X. I transcribed it wrong and tried to fix it by flipping the inequality sign to match, to cover my mistake, but flipped it twice. So 3 mistakes. Sadly, if you make 3 mistakes, that's an odd number of mistakes, and everything's bad. Good. All answers eliminated. At least we're realistic. What does implies mean here? P implies Q means if P is true, then Q is true. Notice this doesn't say anything about the case where P is false. So an example would be something like x bigger than 2 implies that x is bigger than 0. You can tell it's a positive number from this. And if this is true, if x really is bigger than 2, then it has to be bigger than 0. This follows logically in a way. Why not multiply? That is very clever. Solve classically. Heavy logical reasoning with fractions. I think it works out to be the same logical reasoning. Ooh, what's the square peg conjecture? Let's have a quick look. Could we extend it to 3D? Oh, chat, you love higher dimensions. Oh, someone told me about this once. Yeah, you can try extending it to higher dimensions. Go for it. I don't know at all what happens. I think the square thing is really, really good. Should probably be an Oxford Online Maths Club episode at some point, but you know, not right now. Good. Classic bit of multitasking. Yeah, can I bookmark that or something so I remember what I was doing? Let's just have it here. I just saved this page. There we go. Done. Perfect. Come back to that in 2 hours and wonder why I've saved it. Okay. So this is a classic generating a set using some functions kind of question. We've got s, which adds 1 to a number, and we've got t, which does this kind of weird halve it and subtract 1. So beginning with 0, repeat applied in some order. So you could do some s's and some t's, or then some s's again, or something different. So you could do SSTS. And they apply, so s of 0 is 1, and then t of 1. So this is SST of 1, kind of right to left, like closest first, I guess. That's a terrible way of thinking about it. That's why I'm grimacing. Is 1/2 minus 1 minus 1/2, and then sum on that. You get up to 3/2 by adding on twice. Okay, so we clearly along the way there we made minus 1/2. So the set of possible outputs is not this because we made a negative number. And I guess I want to know what the smallest number I can make is. Is the smallest number close to -1? Is it all of them? All positive rational numbers? No, not this, because you can make negative numbers. Look, we made a negative number along the way. All rational numbers are going to -2, the denominator power of 2 when written in lowest terms. This is very similar to that option, which makes me think it's one of those. Or can you make all of them? How low can you go? What's the lowest I go? I kind of think I want to keep applying t lots. So I want to do like t of 0 is -1, and then t of -1 is -3/2, and then t of -3/2 is, oh gosh, -3/4, -7/4. So I'm already getting past -1. I did ages ago, look. So I'm eliminating terms that don't make sense. We're looking for the whole set of possible outputs. Well, that's not one of these. -7/4. Have I got there yet? This feels like a limiting thing because this is -2. It's getting closer to -2, right? This is really close to -2. If I do another one, it gets even more convincing, I think. Not a proof at all yet, but you know. -7/8, take away 1 is -15/8. That's very close to -2. You can prove that that's not a geometric series, but the difference between this and -2 is a geometric series. It's just halving each time. I suppose t of -2 is interesting in itself. You can't actually make -2, but if you could, then it would be, like, weirdly, it would construct itself. Ooh. But -2 is not really in the set, so it sort of accumulates there, I guess. Anyway, I don't understand why it's denominator a power of 2. I guess I can make anything. These have got interesting denominators. Maybe I could do some like adding 1s along the way. I haven't used s yet at all. This would let me make, if I add 1s to this, that would let me make anything that is like 1. And if I add 1s to this one, that would let me make -1/2, 1/2, 3/2, and so on. Maybe if I add 1s to this, it doesn't quite work, does it? Because these things are different by 1. 1's different by about 1/2. Yeah, so I'm missing something here. Maybe you add 1 and then do another s, and that gets used to somewhere different. Not super interested, I think. Is there some like better way to do this? Like, yeah, so like the combination st. If you do s and if you do t and then s of x, means you do t first, so you do ½ x -1, and then s says add the 1 again, so you get 1/2 x. So you can always halve things. So I just can make a supple set of things and then halve them down. Mad. Okay. Josh, if you want to transfer to physics, that is not automatically allowed, but it would be a discussion to have with tutors, I think, if you made an offer. And I should advertise the fact that the maths degree at Oxford contains loads of physics, taught in a mathsy way, which I think is the best way to learn physics. Can I play Dance to the Sugar Plum Fairy by Tchaikovsky on the clarinet? No, I am terrible at the clarinet. And between you and me, hadn't played the clarinet for quite some time when I wrote that personal statement. You want F from MAT 2023? That's a request and a half. And the Sugar Plum Fairy. Oh my goodness. Binary. I think Nav is maybe asking about this sequence, which is just -2 plus 1/2 to the n. Ish. Might be out by 1 on the n. Okay. Very different video to the solutions video is fine. The solutions video is very fast. Other solutions do exist, but if they take longer to say, then I'll have picked the quickest one to say. Lots of people have since asked me about induction. I'm aware of an induction solution. I cannot say it very fast. I think you're probably fine. Also, if I say the induction one, then people ask me questions like, do I need to know induction, and what is induction, and will I be disqualified if I didn't do it by induction? It seemed safer to say the thing that I did. Hey, keeping everyone happy-ish. Floor and ceiling functions, not specifically which section this come under. I think whenever we've brought in a floor or ceiling function, we've explained what it is. We are allowed to introduce new functions. T 1/2 x -1, I guess it's a polynomial, but it's not a function I expect you to have studied before. The police. Oh no, the police are here, or maybe it's the band. Want to know when differential shown by first principles is making it onto the map. Have we actually never done it? Is that a fact? Never. Never. Yeah, I think we've never done it. Good, okay. Hey, are you one of these people who learned about induction with ducks? I met someone recently. She's done a lot of teaching, and she teaches induction using ducks, which makes sense, I suppose. It's another all-time banger of a just mess of sequences. Why is all of the above an option? Oh, because you can be constant, arithmetic, and geometric. If you're constant, then you are technically arithmetic and geometric. So D does make sense. And then there's a none of the above. Brill, love it. This is doing logarithms of powers of A. This looks fine. This looks fine. So let's find some terms, right? Okay, so I kind of see what's going on here. I mean, it's squaring each time, so this is like 2 to the n or something. Whoops, -1. Ah, that was n0. N0. Ah, out by 1. Out by 1. Correct first time. A to the 2 to the n. A to the 2 to the n. And then bn, these will be an's. And then bn will be log base 2 of a to the 2 to the n, which would be log base 2 of a multiplied by 2 to the n. Oh, which is a geometric, but not constant. That would be silly. So it's C, I think. What a weird mix of logarithms and geometric series. How do I know we can't get to -2? I don't think I proved that at all, but one of the options says that it gets close to -2, so I selected that one. Accumulation point. I'm drinking, we are not sponsored. I have a meal deal. I grabbed some sort of lemonade. I think it's the fancy sort. It's very good. Can I be sponsored by San Pellegrino? Would that be alright? It was Laura! Teaching with ducks. You've met Laura, and you've learned about induction with ducks. Oh, brilliant. That's as loud as my microphone goes. I'm sorry. Yeah, really sorry. I can try talking louder, but there's people in the office next door. Okay, we're almost at the end of 2020. We've been spending about an hour on it, but also chatting about ducks. This question is really hard. This question is very hard. Okay. So you've got an equilateral triangle. You're told where some of the corners are. There are like 0, 1,000 or something. And we're looking for the number of points inside the triangle. And some of these options are really similar. So I think it's probably one of those. I mean, my first guess is that we should think about little squares or something to get an idea of how big the answer is. Little squares is something to do with the area. Is the area relevant here? I guess the area is roughly like how many points there are, because the points form the area. Interview emails tend to be at the end of November or start of December. Everything feels like it's running a little bit rapidly or possibly slightly late this year, but it's not officially late yet. Old Douglas Adams quote, "You're not late until you get there." What am I doing? Points inside a triangle. Yeah. I guess I want to know the height of the triangle, so that I've got the idea that there's like a grid of points, loads of them, and I want to know the height. And the height is, I suppose, 500 √3/2. Yeah, √3/2. He says vaguely. √3/2 times 1,000. So √3 times 500, which is about 850-ish. No, yeah, about 850-ish for the height of this thing, right? Does that make sense? I really feel like I'm going round in circles. Yeah, it can't be as tall as 1,000, but it's close to being as tall as 1,000. Okay, so then that would be 850,000, but only half of that, right? Because only half of that, because half of them are outside the triangle in this big rectangle. So that would be one of the 400 options. So maybe now I do an even odd thing. Just checking. Just checking. Hold on, we are checking. What am I doing? Yeah, looking at these ones, 850-ish. For roughly the area, like a big rectangle like this would contain about 850,000 points, but only half of them are inside the triangle. Half base height. One of those options, and then I'm wondering whether it's even or odd. And best way I can think of is it's symmetric and it goes through this point at 500. My best guess is that it's even if the number of points on this line is even, and it's odd if the number of points on this line is odd, and I need to know where that top point is very accurately, because then I'll know how many points are on this middle line. Whether that's even or odd will save the day for me, I think. Okay, so let's work out the height then. Let's do 1.7321 multiplied by 500. Oh, I don't even know really how to do this. Yeah, what am I doing? I hope this makes sense. I really doubt it makes sense, but you know. Sum? How does multiplication work? What am I doing? 6? 6? 8? Oh, that's a familiar number. And then, so that the height is actually 866 and a little bit for this triangle. So that means that there are, starting at 0 up to 866 down the spine. Spine points x, y, they're inside the circle. That's an odd number. And then it's symmetry for the rest. So the answer is odd. No, I'm wrong. Inside the 0 one doesn't count. Oh, that's not cool. That's not cool. Ugh. You've typoed ironic. People have told me I'm ironic. Not the edges. Yeah, thanks, chat. Herb says, sorry, this makes me laugh too much. Herb says, I've never seen multiplication done that way before, left to right, and neither have I. until halfway through, and I wondered what I was doing. Yeah, can you do it left to right? All of the nervous noises I was making while doing that were realizing that I was going left to right and not realizing how to stop. Good, well, we got to an answer. Strongly considered these three for a long time, and then I really settled on odd, and then suddenly it turned to be even because I missed this inside word. Wow. Did I use 4 decimal places? I think I only used 3 decimal places, never mind. And then this is just a bash of loads of triangles and parabolas, I think. I guess the trick is that this one is the best. Y equals 2 minus x squared is some nice parabola like this. And then all of the others are like switching x and y, which means that they go, or there's an upside down one in there as well. Yeah, there's this one as well, which is y equals, the boundary for this one would be y equals x squared minus 2. Ooh, sorry. I mean to shake the screen like that. And then there's some that go the other way as well. They go through the same points, I think. Really unpleasant. Really, really unpleasant. Yeah, my drawing's quite bad. That's 2, that's root 2. So then there are some more parabolas that come through like a wrecking ball. Never felt that. There we go, like this. And symmetrically. Some go the other way. Shark's head like that. Switching x and y. What a horrible mess. There's 4 parabolas. But the only bit that you really need to focus on is the top right corner, because it's got this nice symmetry. So the top right corner has this kind of parabola thing going on. Where they both go through 1, 1. Oh, not 1, 1. No, not true. Oh my goodness. Where do they go through? Oh yes, 1, 1. So this is a bit of a pain, but you can do this like this, to do like a parabola integral up to 1, and then you could do a parabola integral going the other way. Oh, I hate this. Yeah, you could subtract that square and then add it again or something. Yeah, symmetry around this line or something. There we go. Okay, integrate the parabola 2 minus x squared from 0 up to 1. That gives me the shaded area there. And then what you do is subtract the square in pink, subtract the pink square, multiply all that by 2 to get in this bit as well, going looking from right to left on the top bit, so giving the kind of curved bit above the square, and then add the square back on again. There's probably a better way to say that. PDF 40. Every question that week. Look at this. Oh, very different method. Question 5. Yeah, you're fine. I think I said that in the video. Yeah. Can I plug my email? Isn't my email literally on screen? Hang on a second while I just squint at the screen. Right. Sorry, my email is not literally on the screen. But there is a link to the MAT Livestream homepage, which has a contact us link at the bottom. Can we have extra plain paper if we run out on the mat? I only got lines last time. Not under my control. Talk to your test centre. I don't mind what you write on. We're only marking answers for the additional test. So yeah, I would hope that you could bring. Can you bring your own plain paper, or does that look really suspicious? I guess that looks suspicious if you turn up with a stack of blank paper. Yeah. You're asking we're asking a test centre to print it, so they've probably got access to a printer. Printers eat blank paper, so maybe you could ask them to bring some blank paper from the printer as well. I don't know. I did forget the dx on the integral. You are correct, and it's a bad one because I then wrote some more stuff, and it's not clear if it's inside the integral or not. Thank you very much. Close your brackets, close your integrals. Some of these catchphrases are not all timers, so we're trying out a lot of catchphrases. The show is not quite developed. What am I saying? The show's developed loads of catchphrases. The show's very catchphrasey. Is squared paper not cheating? Oh no, you want squared paper? Nobody's giving you squared paper. Where are you getting the squared paper? What are you going to do with your squared paper? Oh, I know what you want to do with squared paper. You're going to count out 1,000 squares. You're going to draw a massive triangle, and then you're going to count all the dots, and you're going to find there are exactly 432,512. That does sound like cheating. You're right. I'm onto you, counting 500,000 dots. I'm being silly. I can't think of an advantage of squared paper. I'm sure chat will come up with an advantage that squared paper would give you. But the chat seems quite good at working out how something could or could not be an advantage. I'm not saying that's being mean, I'm just saying inventive people. Herb likes squared people. I like squared paper. Good. How does the square root end up in the answer? Yeah, good question. Good question. What have I done wrong? Yes, good question. Good question. What have I done wrong? What have I done wrong? Why are they integrating onto root 2? What is going on? When I say they, I'm reading the answer that I wrote for this question 2 years ago. 3 years ago? What have I done wrong, chat? I was very convinced by the thing I wrote. Now I'm much less convinced. Take off the square, double it, add the square back on again. I've multiplied by 4 or something. I agree I've missed a multiply by 4. Why is there root 2's in the answer? Help. Don't integrate up to 1, integrate up to square root 2. I mean, that sounds like a plausible fix. Did I rush this? Yeah, I rushed this. That's not the 0.11, is it? Maybe it is. Yeah, it's not the 0.11. What's the solution to this? It's a weird point. Don't like it. Okay, so not 1. There's your answer. I think that's not 1-1. Yeah, it's not 1-1, is it? I've convinced myself it's not 1-1. 1-1's on the curve, but is it not on? What even is that curve? What a fun life. iPad instead of paper. If we're doing it at home, I think we're letting people work their answers out. I mean, you're in a team school, so you have access to a computer. I can't ban you access to a computer. I'm nervous because it's going to look like you're using a calculator for the whole thing. I think I prefer it if you wrote on paper, if that's all right. Oh yeah, 6 o'clock. It's 1-1, but you've lost some area just to the bottom left of that region. Interesting. Interesting. What's the question? Oh, the region where all 4 of them hold. I don't know what I was calculating. Oh, my shaded area is way too large, right? It includes a whole bunch of stuff I don't want. Oh, rubbish. Oh, no. What have I calculated? What did I want? Right, this really was the 0.11. That was not the fix. I was wrong again. The question actually wants not that shaded bit that I've been calculating. I didn't. I always read. You should always read the question. The question wants this area where both of these things are true. Oh, this is a mean question. What a hard amount of maths. So maybe I could integrate a parabola looking across. Maybe I could integrate a parabola just for this bit here, just for that tiny sliver, and then multiply by like 8 or whatever and add on some squares, and I'm good. But yeah, that's then integrating 1 up to root 2. So 1, new plan, this thing, multiply by 8, hope for the best. Add on 4 or something for the squares, call it a day. So one of the options obviously got a +4? No. Right, good, okay. Brill. Having a whale of a time. 6 o'clock, don't forget to look away from the screen if you've been looking at the screen for the last hour. Don't forget to blink, and don't forget to enjoy some delicious Reed's Can San Pellegrino water. Right, good, okay. It's not a good sign when the person who writes this question gets stuff wrong. I am rushing. I'm trying to do too much. I need to slow down. Also, I have an unfair blind spot, right? That I read the question and I think I remember what it said, so I'm not really reading. I'm trying to remember. What I've learned twice already in the last hour is that I cannot remember what the question was, and I should stop trying to rely on my memory and read it very carefully. This is not a problem that you face because you haven't seen the question before. It's a sort of blind spot you develop by being overconfident when talking about something you used to know about. You have to be very conscious of it. Excuses. Yes, I will use as many excuses as I need. It's part of the plan. There was a question in there about whether I'm teaching for New College next year, and next year is so far away. Next year is like unbelievably distant. Am I going to come back for the whole summer school? You were at that summer school. I don't know if I'm doing a whole week. Who knows? Maybe. I've been sent some dates, but they're all in there like distant future, way after MAT 2023B. 21B is bad. Oh, they're doing branded ducks. We got some maths summer school chats going. What are we going to do then? We've got about an hour, and I think I want to select questions. So I want to start skipping things if I think they're fine. So I'm going to go faster. Right, but we're getting more familiar because they're more recent. Okay. So this one's all about imagining, converting all of them, to cos of x degrees where x is small, and then choosing the one with the largest. So this is like cos of 20 degrees. Cos of 20 degrees is a little bit smaller than cos of 10 degrees. We're nowhere near 90 degrees or something like that. We're in this bit of cos, where that's cos of 10, and that's cos of 20, and it's smaller. So we're looking for the largest, so it's not this one. And continue like that. You can convert all of them. So this is cos of 15 degrees, for example, which is also out. That one's 15, 20, no, that one's cos of 5. Sorry, I should stop talking. Cos of 5 degrees. No, is it? Yes, cos of 5 degrees. Using some sine and cos rules. And that one turns out to be the biggest, I think. Good. This one is about expanding something which is not the binomial expansion, but you can make it like the binomial expansion. If you read it as something like this, now it is in the format for the binomial expansion, and you only want the first few terms because you just want x cubed. So you might want the terms that have got x squared plus xy to, what do you want? You want this not to the 0, not to the 1. That's not interesting. It won't have any x cubes in it. You should maybe think about this term. And you should, I don't know what this is, n choose 2 or something. And you should maybe think about this term. But I don't think any of the other terms are interesting because now they've got too many x's in. Before, not enough x. Later, too much x. So somewhere in between. And I think this one is going to have coefficient n choose 3. And this one is going to have coefficient n choose 2 times 2 or something, because it's the cross term in the middle that's x cubed y in this case, which comes with a free factor of 2 from the squaring. If you've already used all the papers, and for some reason you've decided you want to do more preparation, then please find any other maths. Any other maths. Counting. We've got some graphs. This one's just weird. I mean, it's D, which is weird. You can check some values. So check what's going on when C is equal to the number 1, for example. In that case, we're talking about a triangle or something. C is slightly less than 1, fine. So we make C slightly less than 1. We're talking about something that's almost a triangle. So it's almost the value 1 up there, which is actually like most of them. And then it's mentioning that this increases, the rate of increase decreases a little bit at the top. Oh, that is weird. That's really weird. I don't know. Chat, have you got any ideas about how to do that? Plugging in n equals 3 is a good strat for the previous one. I agree. I can't see anything wrong with Tamura papers for practicing multiple choice maths. Sounds quite sensible. I don't think you should try and do all of them or anything stressful like that. I think really what I want is you were already prepared for the maths, right? You haven't got worse at maths since then. It was like 3 weeks ago. Or if you have, then, oh gosh, maths at university is a whole year away. So if 3 weeks is enough to forget all of your maths, then a whole year sounds like quite a lot worse. But you should think about retaining maths a bit more seriously if that's genuinely a concern for you. Really, I think you were already prepared, and now here's just some more questions. Yeah, you can find it and get A is, oh gosh, ooh, C plus square root. Okay, you can kind of solve it. Oh, C plus square root of something. So that tells you it's bigger than that, but comes back down again because the square root term comes. Oh, okay, that's clever. Yeah, sure. Okay. We should actually go and solve these equations. Yeah, I like that. I like that a lot. So you should go and solve for this. Work out the area of this by doing. Oh yeah, okay. So that's y equals c. So this little triangle here. Once again, I've got myself into a position of splitting up an area and hoping I can calculate. So you've got some little triangles and you've got a big rectangle. Or if you know the area of a trapezium, then off you go. Time to shine. Wasn't prepared. More prepared now. Thank you, technical issues. Here we go. And also, hopefully, the preparation will stay with you for the next 3 weeks. Right? And in longer, maybe. Who knows? I cannot tell you which of paper 1 and paper 2 of Tamura is which. I am just generally advising people that doing maths questions is good for them. yeah, what was going on here? Particle, so 100, time 100. Starts at 0, 0 of initial speed 1, moving towards x equals 1. When the particle reaches x equals n, oh, it's a sort of, it gets faster. Its speed immediately, no, slower. Which direction is changed, unchanged. So it does this journey in time 1, and then it gets to point 1, at which point at x equals n, its speed immediately changes to 2 to the minus 1. So over here, speed is 1, and now speed is 1/2. So now it takes 2 units of time, or whatever, to get to the next point. And then I guess it's going to take 4 units of time. And the question is just like, where is it? Where is it T100? And I suppose the answer is it is done 1, 2, 4 geometric series, adds up to, you could get up to about 63, I guess. It's somewhere in between the step that took 32 units of time and the step that takes 64 units of time. Because once it gets to this point here, it will be a total of 127. Once it's at here, it's t equals 63. So it's sort of somewhere in between. Somewhere in between those. Is that good enough? Somewhere between, what is that? 1, 2 gets you to x equals 2, and then 7 gets you to x equals 3, so it's 1 less. So this is x equals 2, 4, 8, 16, 30, 64, 6 equals 6, x equals 5. So somewhere between 5 and 6. Does that line up with any of the options? Not really. No, not at all. Fair enough. Is it physics? It doesn't even have any units. If it's a physics question, I have severe notes for it. Somewhere in between linear interpolation, I think, out of the 64s. Oh, what am I doing wrong? It feels a lot like it should just be something easy, right? Like, how many of these have I got to go? 37 over 64, but it's not that. That would be mad. That would be 300 and... Ooh, I'm liking the look of D now. 320 and 37 times proportionally. I'm liking the look of D. Am I just out by 1? 360. This is my plan. Work out where it is at particular times. In between, it's travelling at a constant speed, so in between. I believe that if its speed doubles every time, then it escapes to infinity in finite time. So that's exciting. 64 in denominator, so it's D. That's the correct intuition. Yeah. Oh yeah, these are supposed to be 6 and 7. I'm out by 1 over here. Did that bit too fast. How was I going to spot that? So 7 time total gets it to 2 to the, I don't know, 3 minus 1. 63 total gets it to 2 to the 6 minus 1. 2, 4, 8, 16, 30, 64. Yeah, I can't count. I was trying to count powers of 2 on my fingers. I think I miscounted. So what am I supposed to do? 6 plus this? 360 and 24. Still feels like I'm adding, just calculate. Yeah, it's that one. 410, 421. Yeah, okay, good. Okay, out by 1 over here, I think. But my plan there was to write down where it is at particular points in time. Polynomial equation, but it's actually a softie. So I did remember the trick for this one. Hiding in there, there's an x squared, a 2x and a 1, which look really nice if you put them together on the right hand side. And actually the left hand side then looks even nicer not to have them, which is not that bad at all. So you've got 2 different cases, and then you've got some quadratics to solve. Oh my goodness, we want those 4 solutions to happen, and we want them all to be exactly 4 real, so we want them to be different. So there's some captures in there in the algebra, but I think this is fine. Why is the research just multiple choice questions, says Josh. Would you not want to see how people answer the long questions without questions? Well, I would like that a lot. Can I run that in 2 weeks' time and with varying amounts of remote invigilation and test center support and no time to mark it afterwards? Sadly, no. Oh, you think the quadratic in K? Ooh, that does sound mad. To get 4 solutions. Wait, so you get discriminants? No. What? Quadratic in K? Epic. Odd. Can't be simpler than 64s. Hang on, I've just seen this anonymous thing down here. This is lovely. There's real multiple choice logic. People in chat didn't, not so good. Not so good with the let's all redo it all. What is going on here? Point A has got coordinates 3, 4. Those are nice numbers. The origin 0, 0, and the point 3, 4 both lie on the circumference of a circle, so I know where the centre is. The diameter of C of the circle through A also meets C. What? Oh, circumference, not the diameter. Come on, James. Both lie on the circumference of the circle. This diameter of C through A also meets C at another point B. It follows that the coordinates of B could be either. Oh, this is between B and the origin. Oh my goodness. Oh, this is one of those right angle in a semicircle thingamies, isn't it? Is it? Isn't it? No? Maybe? Very uncomfortable with this. Feels like I just want to write down loads of distances. Oh yeah, hang on, I know loads of stuff. These are at right angles. This is the origin. So I know the equation of this line. This is y is 4/3 x. So this line, the one that goes through B, is y is -3/4 x. Easy peasy, B is either here or down here, I suppose. If there's two possibilities, because diagram dependency, maybe the radius went this way instead. Maybe the diameter went that way instead. So I need to point on the line with distance 10 away. That looks not too bad. Is it 4, 3? No, that's not distance 5. It's double that. It's D. I'm remembering that 4, 3 has distance 5. There is a right angle that helps a lot. If the question says largest when talking about the numbers, I mean biggest absolute value. I think that means most positive. So positive numbers are larger than negative numbers. I agree that is ambiguous wording. Now that you've suggested it. Hey look, which of the following is a square number? Or which of the following is the square of 1, 2, 3, 4, 5, 6, 7, 8, 9? Can't remember how I got away with this as a question, because this is about multiples of 9, isn't it? All these numbers are basically the same except the one of the middle digits. So we should use like a multiple of 9 thing, I think. It's like digit sum. And we did something that was a little bit like that on the main mat this year, and people were very upset about it. Warning sign should have been, how did people feel about this in 2021? It's very minimal to digit sum. Yeah, what Josh said. I'm not going to do the digit sum stuff now, but that's a multiple of 9. And only one of these is. I can't think of any other ways to do this. Let me know in chat if you've got any other ways. Use the left and right multiplication method. That is excellent. Yeah, off we go. Just when I thought we didn't have any more in jokes in us. So the left to right multiplication method is where you just write down from left to right and you try not to panic too much as you go through. So this has got loads of zeros at the end, and we're going to go left to right. So we're going to try and double it now, which involves writing down like you have to keep adding when you go down. Oh my goodness. Is that enough? We did the bit. We did the bit, and then you keep going. That's 2 times, but it's a bit to the right, and you keep going, and you add them all up, and you carry over the ones, but you have to write them all down because you didn't remember to carry them right to left. It will take a while to type, but I have another way. I'd say, don't worry about it. Keep your secrets, if you like. I'm moving on. Maybe that's a polite thing for me to say. I'm going to move on. You can type it if you like. Was there matter equivalent? Ah, yes, it was called step. And step's been going for so long that step database. You can look up the step. Slip of the tongue. You can look up step 2010. We thought it was quite hard at the time. Right. Okay. I vaguely remember how this one works. It's a sort of function question, which is just horrible. We don't do a lot of these on the mat at all. I think you can plug in numbers and just sort of solve stuff though. For any real positive numbers, if function is for any real positive numbers x and y, and all satisfies that it seems positive. And I guess the hint is to try. The hint to try something in x is 1 and y is 1, because then this would be true, and that tells you that 2f of 1 squared, if I multiply up, is 1. So f of 1 is 1 over root 2. And then I think what happens is that you get a quadratic equation for f of x. If you put in y equals 1, but not x equals 1, you get this, which is a quadratic for f of x. We know that f of 1 is now 1 over root 2. So now it's a quadratic. It's a quadratic. And I think it turns out to be the constant function. You take the positive root because you're told it's positive, and that's 1 over root 2 is the solution to that equation. Explain the difference between university maths and A-level, as a lot of people ask me. Let's do both of these. University maths involves a lot more understanding of what you're doing. You can have a bit more intuition in a university maths problem for what the answer should be like and what things might happen during the answer. Whereas at A-level, often there's maybe only one idea, or it's immediately obvious to you what the idea is. In university, maybe you're trying to prove something, which is not something you do very much at A-level, but maybe you're trying to prove something, and you might have an idea for what style of proof or what ideas will be important during the proof. Sorry, I used the word idea too many times there. You'll have an idea for which concepts might be useful during the proof. Or you might be trying to do some complicated calculation, but you'll have some idea about what the result should be. Not just what calculation steps you'll do along the way, but what the shape of the thing should be and what the result should look like based on your intuition of similar problems. That to me is a big difference between A-level and university, that you have some sort of meta-level understanding, some sort of pilot process, that you have the hard work of doing the maths, but you have some sort of larger scale look at what's going on. So you're not just going line by line, you'll also step back at the same time, step back, out of body experience, look down on what's going on, and have some idea about where this is going. I think that's the biggest thing for me. And then difference between university, no, hang on. Go for it, just do the squares. If you do worse on Mat B than Mat A, that probably won't happen very much. But if you do worse on Mat B than Mat A, I'm saying that if your Mat A score was good enough, your first Mat score was good enough that you would have been shortlisted, then you should be shortlisted anyway. If both scores are not good enough to be shortlisted, then I'm afraid probably it's probably unlikely to shortlist you if both scores are not good enough to be shortlisted. Losing focus when going through lots of questions. You are asking the wrong person. I have no focus whatsoever. For example, what am I doing? Where am I? We got some logarithms and some integrals. Very nice. The trapezium rule is not on the syllabus anymore, not since about 2014. It is not on the syllabus for the additional mat either because we're using the same syllabus. Warwick's asking for 64 on the mat. That is interesting because I don't currently know where that number's come from. Interesting, if true. What does that translate? I don't know where that number's come from. I imagine if you've got enough from the map, they must have chosen a number. Strange. I'm glad it doesn't work like that for me, in a way. Oxford gets to wait and look at all the scores and then decide, based on the scores, who to interview. Whereas Warwick have to do, like, just go on with making offers, I guess. Gosh, it's all tricky. Yeah, FSM is, we think it's correlated with a lot of stuff. I mean, in some sense it's crude metric, but in some sense all this stuff's kind of correlated. We are very interested in general in finding people who, situations like, let's do tech disruption again, right? People who have had some disruption or something more major going on that means that the raw numbers we're seeing aren't a fair measure of how well they would do at Oxford. We're not just trying to take whoever's got the largest numbers, whoever's got the most positive numbers. We're looking for candidates who do well on the course at Oxford, which we assess in lots of different ways and with lots of numbers. Whew. Warwick sent out mark. There you go. I gave you. I thought maybe they knew something I didn't. Mark requirements for the map before the map has even happened. Tough, right? Tough job on both sides. Very tough job. Good. I reckon you can rearrange these. You do some stuff. They're all squarey stuff, aren't they? So I think if you can build this out of these, then you're good. Because then it'll just be like some combination. Hang on, that's tan. What's that doing? So this is like sine to the 6 over cos squared. Oh, I see. So there's only really two things going on here, right? There's log c sine squared x dx. I remember this question. Oh no, that's the danger thing. We'll call that I or something. It's good to give things names. J. And then this one says that 3i minus j is 1, and the other equation says that I plus j is equal to 3. I'm going to solve. 4i is 4, so I is 1, and j is 2 or something? Yeah, j is 2. What do I want? I want 2i. Sorry. There's a button on the thing. I need to disable it. It's 4. Is it 4? Sneaky look at the solutions. Yes, 4. Hey. When is MAT A? So MAT A is what people are saying for the original MAT test. They're saying MAT A for just the normal MAT, because they've noticed that I've been describing any additional MAT that we run as B. It's not the best numbering system, is it? It's like when people put final underscore v2. You know, it sort of reveals that if you're on plan B, but you didn't really have a... Oh, never mind. I think this is a nice question, but nobody else does. So you take a cubic like this. You try and do a line. It's normal. There is a straight line that's normal at 2 different points, if and only if. The idea is I think that if it's got a positive gradient, if it's normal here at 0. Oh no, wait. Oh no, I hate this. It doesn't have to go through the origin. I thought I had to go through the origin. No. Okay, crazy. I don't remember this question. So normal would be like this. There's normals, and then is it going normal to the curve again? So think about the gradient. The gradient is something like this. So at x equals a, that's 3a squared minus k. I've gone on to chat. And then the actual curve is, so the actual equation of the normal would be this. Oh my goodness, plus some constant on here to make sure it goes through x cubed minus kx. This is grim. What am I missing? I'm missing some sort of trick. Why am I missing a trick? Chat, tell me. Why have I drawn a hairy line? FSM is something people are saying in chat at the moment about free school meals. People are latching onto it as a kind of thing that maybe I am fair or unfair about. It's been a thing for the last couple of weeks. Is university maths as fun as math? It's better because in university maths, it's much more likely that you know what's going on. Math is like a bit of a clown show, really, in a lot of ways. It's all just it's crazy. It's everywhere. university maths, you've at least been to some lectures first, so you've learned the material, and then you do some questions. And the questions are not clown show, crazy, wild, really out there. The questions are a bit more closely related to what you're doing, in a way that's still fun. Lots of room for thought. Why have I drawn a hairy line? It is a good question right now. I guess I'm thinking about all the potential normals to this cubic. The normals might look like this, or this, or this, or this. These ones may be very suspicious. Or this, or this, or this. And by glancing at the solution, I've realised there's some sort of symmetry going on. That if your line is going to be normal to the curve in two places, it's going to have the same gradient there, isn't it? And there's a symmetry to this. That the gradient is 3x squared minus k, which repeats values for positive and negative x. So if this straight line really is normal to the curve, then the gradient of the curve will be the same at these 2 points. If that really was somehow the same line, then the gradient of the curve will be the same for those 2 points. And by thinking about the gradient as 3x squared minus k, we see that those points would be symmetric siblings, plus and minus values of x. And now that means that, now I think that means that the line goes through the origin. I can't draw it going through the origin over here. Can I convince myself that's true? If you go through A, B, and also minus A, minus B, yeah, then you definitely have to go through the origin as well. Lines are linear. You can add together. No, it's just nonsense. Shut up, shut up. Yeah, you definitely go through the origin as well. Just be confident. Just air of confidence. Yeah, go through the origin as well. So this line would be like y equals mx. And now we're in business, because now we can start to solve some equations like is m equal to 1 over 3a squared minus k, and does the value match up so that ma is equal to 4i cubed minus ka. And you can solve both of those. Stuff. Why is the gradient of the normal 3x minus k? I'm trying to write 3x squared minus k, and that's actually the gradient. That's the gradient of the curve because I differentiated it. Maybe poorly. I think I got it. And then I'm trying to do this like minus 1 over thing for the minus 1 over for the gradient of the normal, but I'm not doing it very convincingly. I'm being very inconsistent and wrong all the time. Am I getting tired? I might be getting tired. Am I getting old? I might be getting old. Does the CS department use FSM? Welcome to acronyms. Does the computer science department use free school meals? Yes. Also aware of the concept of free school meals. Also signed up to the same university-wide access and participation plan. Shortlisting is done by individual colleges. So the college that's considering your application to shortlisting, at interview stage, it's likely that you'd be interviewed by at least 2 colleges. Shall we have a quick look at last year's BE paper as well? We've got 20 minutes in. Okay. Oh my goodness, we're doing a linear sequence, right? We did 60 minutes on the first one, 40 minutes on the next one, 20 minutes on 22B, and 0 minutes on 23B because I'm not allowed to talk about it yet. Right, good, okay. Linear sequence, excellent stuff. I look forward to doing minus 20 minutes on the next one. It's a weird thing to say in many ways. Right, probability. Everyone loves probability. I think this is just 2 or more times out of 3 times is your standard binomial probabilities. And then this one is a little bit weird because it is cos squared versus sine squared. Those are probabilities that add up to 1. I think that's the gimmick. The answers are all in terms of sine squared, which is a bit, because it says cos squared up here, so you've got to do some conversion to get it in sine squared, and then the options are just 3 different plausible looking polynomials in sine squared. Good, okay. Explain 2022 G, fine, cool, we're skipping to G. This one, yeah, 22BG, the BGs. There's Tamura as well. If you want more scrapped math, that's not fair. If you want math, no, that's not how it works. Still, it's just not accurate. If you want math questions that are not math questions, there's Tamura. I was considering doing a sort of diss, but it wasn't professional, and I've retracted it. I like Tamura questions. It doesn't even make sense. Right. They have a whole paper that's like logic and induction and all this imply stuff that somebody asked about earlier. Imply stuff. I think that's paper 2, but don't hold me to that. I guess, have I got any rejected math questions hanging around? I kind of believe in math questions that if you've got a good idea for a question, then even if it doesn't make it onto the mat, you should try and rephrase it and bring it back in the future. Good, right, okay. Given that f of x is a solution to this, which would mean that f prime is equal to f to the quarter. Nice. I like that a lot. It follows that one of the following, all of these are like k times f of x, right? There's some constant, is a solution to this. So it satisfies k f prime, because when you do the derivative, the constant at the front doesn't matter. It stays at the front. And on the right hand side, it would have to be a solution to kf to the quarter. That's what it would have to do in order to be a solution to this differential equation, to this equation. I haven't even called it an equation or a differential equation in there, but whatever. Is Tamura a Cambridge test? Oh yeah, I suppose it is. Good. Oh, long answer questions like Matt style. Sorry, yeah. And you don't like step? Yeah, that's really tough. It's quite hard writing those questions, and I'm not sure I can think of many people who do it. For British students, I would point you to the BMO, and actually anyone. Why am I saying British students? I think they've got some past papers online. BMOs, I think, are quite hard though, and quite specific to a particular syllabus that isn't the same as the math syllabus. Really hard, in ways that people would be very cross if we copied BMO questions for the math. Maybe hard questions are very good for you. Okay, we're almost there actually with this question because that's been requested in chat, because we knew already that the derivative of f was f to the quarter. I don't know what the function is, f of x, but I was told that its derivative is the same thing as the function of the quarter. So I'll put that in here, and I'll do some laws of powers over here. That's pretty good. So I guess provided it's not 0, I want k to be 2k to the quarter. And then some rearranging goes on, right? Oh gosh, is this going to be one of the options? Please be one of the options. I want this so much. Yes! Double check that I'm not lying to everyone. Yeah. Okay, we got to an option. All of your graph bits. So people are sometimes asking, how long in advance was this prepared? And do you have next year's paper ready? And also, can you just release everything that's not currently a math paper? You can't do all of these. There are actually episodes of like the Maths Club or something, where we've been doing like a Maths Club thing, and it's kind of fun little calculation. And I think this would have been a good math question. Currently broadcasting it live. Can't use this. In some sense, we're getting through content extremely fast. It's great fun. I love it. That wasn't sarcastic. That was content is always good. Right. People always vote for more content. God, I'm losing this, aren't I? What is going on? Were you sleep deprived? An Oxford mathematician until you couldn't remember how to do the area under a parabola. Watch this one video to find out what happened next. Good, okay. How many values of n are there such that f of n is 3 and also n is a multiple of 35? I hope it's none, but because I don't want to calculate this up to f that f is 35. Oh, hang on a minute. Yeah. So it's adding values of f, right? So there's good news. If it's going to be 3, then not that much adding has occurred. What does this say? This says that f of 2 is f of 1 is 1, so this is 1, and also f of 4 is 1, and I suppose f of 8 is 1, f of 16 is 1, and f of 32 is 1, and so on. Powers of 2. Nice. Right. And then when is the function 2? Well, the function has only been 2 if it came from this thing giving the number 2, or I suppose doubling. Yeah, So if you've got a number, if you've got an even number with f equals 2, then divide it by 2, because it must be true that f2n is equal to f of n. So keep dividing, keep going down until you get to an odd number with f equals 2. Those are the ones we should study, because obviously you can always, once you've got this odd number, you can multiply it by 2s and just keep getting new values of f that have new values of n that have the same f, new values of input that have the same output. Turns out 17 or whatever. Oh, I'll forget them. 34, 68. Why do they pick such a large number to do as an example? We should think about this odd number thing. And the question is here: if the thing on this side is 2, and these are all positive integers, so we've got 2 on the left-hand side, and we're looking for some positive integers, not 0, I suppose. Yeah, it's thinking never give 0 because it always starts at 1 and it keeps getting larger. So okay, so we're looking for positive integers larger than 0, where when you add 2 of them together, you get the number 2. And these have got to be 1 and 1, right? Because 1 plus 1 is 2, and anything else would be larger. Okay, so these would have to both be n and n plus 1, both multiples of 2. That is a bit weird, for n and n plus 1 to both be multiples of 2. It's the sort of thing that only happens with very small numbers, right? I think it's this. Powers of 2, sorry. Losing it. Powers of 2, because we agreed those are the ones that give the value 1. So I think it's 1 and 2, which gives us that n equals 1, which gives us f of 3 is 2. It's the only kind of odd number, only odd input for f equals 2. And then of course you can double it, you get like 3 times powers of 2. You can go 6 and 12 and all of that stuff is also going to give you f equals 2. This thing's kind of hyperactive, it just keeps like doubling the input. Whoa, same output, brilliant. And what do I think? Yeah, I suppose this is a true comment in chat. It's either 0 or infinity. Because if you've got one example with f of n equals 3 and also a multiple of 35, then you could run it through this mill quite a lot of times and double it and double it and double it, and you'd generate infinitely many. So it's either 0 or infinitely many, because you could do this doubling trick 4 or 5 times or forever. Okay, no, good observation. I think I'm about to tell you that it's 0, so let's do that. Yeah, it's a fancy way of saying okay, never mind. Okay, how do we make 3? So similar argument, we want like an odd input that gives f equals 3. So that would be 3 is equal to, and then I suppose 3 could be made by 1 plus 2 or by 2 plus 1, but in either case we want a power of 2 and then a power of 2 times 3, or a power of 2 times 3 and a power of 2 as consecutive numbers. I want them to be n and n plus 1 for the inputs here. And this seems unlikely as well. Both of these are even. So how can they be consecutive? Unless one of the numbers is very small, in which case you've got some different examples. You've got the numbers like 2, 3, and 4, which give you examples like f of 5 is 3, and f of 7 is 3, and then multiply by powers of 2, but that's it. That's all you can do. So I jumped a few steps there to go from these suspiciously consecutive, even-looking numbers, and being consecutive numbers actually. That was one of them's got to be odd, right? Yeah, multiples of 3 going on in there as well. So this is the place to look. Okay, so none, because the times that it is 3 are 5 times powers of 2 and 7 times powers of 2. There is a pleasing pattern here. 1 times powers of 2 gives you f is 1. 3 times powers of 2 gives you f is 3. 2, sorry. Counting. Counting is hard. And then 5 or 7 times power of 2 gives you f is 3. Tricky question. What's f of 35? Where does that come into the pattern? I mean, f of 35 is something, right? Where does it fit into the sequence? I guess we need all other odd numbers to appear in the sequence. 3, 5, 7. Yeah, I want to know about 9 and 11 and 35 and stuff like that. Homework. Explain A from this test. Oof. I thought I did already. Oh no, I didn't. I kind of didn't really do it at all. So heads with probability P, and we want either heads, tails in some order, or 2 or more times, so maybe 3 heads. This thing has got probability cos squared alpha cubed, and these things between them have got probability cos squared alpha squared sine squared alpha, and there are 3 of them. It's cos squared alpha squared because you need, for example, in this first case, you need to get head on the first one and head on the second one, and then crucially you need to get tails here. To actually get heads, tails, you need the cos squared alpha probability thing to happen, to land heads, but then you also need that final one to be tails. Otherwise you'll double count it. If it's maybe heads, then it's this case, which we counted separately. And then I think you have to convert everything into sines. So it's like 1 minus sine squared alpha cubed over here, 1 minus sine squared alpha squared over here, there's a sine squared, there's a factor of 3. I remember reviewing this question and taking about 10 attempts at the next bit, which is multiply everything out and group the terms together. Like, there's definitely a 1 in there, but they've all got a 1, and then, oh my goodness, I have to multiply some squares. Maybe write u equals sine squared, but you be the judge. Oh, was that good? Okay, phew. Just to work them out, so f of 13, only increasing from there, bigger than 4, coming down 3 again. No, I think it's low again. F of 16 is pretty small. F of 16 is 1. Oh yeah, this one is bigger than or equal to 1. Which is quite large for a probability. You could test some values. So this doesn't give you the function, but you could try, what happens if alpha equals 0? Then this probability is probability 1, so it will definitely give you lots of, so it will definitely happen. So the answer should be 1 in that case, and these all work. And then you think, what about alpha equals pi, or something that makes cos squared 0? When's cos squared 0? This one. And then it never happens. So you can go and plug in pi over 2, and then you get a bit confused because there's all these plus and minus signs. And I think there's a couple of them are acceptable and a couple of them are not acceptable. So it should be 0 in that case. And that's like plugging in 1 for all of these things. So it's not good. That's not good. That's not good. That is good. It's that one. Okay, so the question's quite amenable to that kind of trick. Cos squared alpha could be 0, in which case the answer should be 0. Only one of these is 0 when alpha is pi over 2. Maybe I could have been cleverer with the plus and minus signs. Anyone think of this in chat? Can you ignore the final flip? Yeah, so this gets you into a lot of trouble. It's a plausible way of thinking, right? You do like this probability tree, where you stop early. You say, well, I'm done now, so I won't think anymore. It's a sensible way of thinking, but it gets you into a bit of trouble that you're tracking cases separately, in a way. The neater thing to do is to always keep going out there and make sure you count the cases. The neater thing to do is to count the number of heads that occur and use that to split down your cases. So there's 3 heads over here versus 2 heads over here. That's neat because it lines up really, really neatly with the maths that you do for a binomial expansion. So if you have like tails or heads to the power of 3, then you get this kind of like tail cubed plus 3 choose 1 tail squared heads plus 3 choose 2 tails heads squared plus 3 choose 3 heads cubed. And this lines up just really neatly with the maths that you're doing over here versus over here. These things kind of mean the 3 ways that you could have 2 heads and a tail. So this means I don't know if that's helpful. It's probably not helpful. Everyone's like, what's capital T? But sorry, there's some really related maths going on. I guess maybe like the T is like the probability of tails or something. And then we're using really heavily this kind of commutative property of the probability of things happening in particular order. It doesn't matter what order they happen because they're independent events. Whatever. Not right now. 5 minutes to go. Which of these questions is important to talk about? Not this one. This is just some sketches. If you don't Don't like it. Ooh, it's one of these, isn't it? One of these goes to 0, starts at 0. Yeah, those are kind of its key properties. Starts at 0, goes to 0. Is negative, I think. Positive? Yeah, one of those or the other. Those are enough observations. 0, 0. Is it positive? Another inequality stuff, messing around with different cases and multiplication. Let's not talk about it. Oh, the life ring question. So the first one sets up, you're between these two circles, 1 and 4, radius 1, radius 2. And this one says that x squared is bigger than 3y squared, which means you are somewhere over here. Or over here. What is that? Mod x is bigger than root 3 mod y, if you know that notation. Or if you prefer, it says that x is bigger than or equal to root 3y, or x is less than or equal to negative root 3y. Got an and in there? I think I got an and. I don't know what's going on. Oh, I need to worry about positive and negative y. Ugh, horrible, 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 horrible. If you prefer, there are approximately 4 cases to worry about where x might be positive or negative, y might be positive or negative. I don't know, 4 cases to check. But you get quite a pleasing life ring picture, and then we're asked for this region. And it says total, and it says both, which is slightly different, but the total is supposed to be a row clue. You take both of these bits. But x equals 1. Is it e squared or is the... I panicked because I thought... never mind. Could we do e? Request for e with 3 minutes on the clock. Yes. E is called a Carlisle circle, if you would like to see this again. See, now we're getting recent enough that I remember what the maths is as well. 0, 1, and p, q. Whoops. The trick is this time, it is the diameter. So the center is in the middle of that line. With coordinates like, oh gosh, what is that? P over 2 is like halfway along. P over 2 and halfway up as well. So between 1 and q, like the average. Yeah, that's a good way of thinking about it. The center is at the average of the endpoints of the diameter. No, I've said it out loud and I don't like it. It's true though. The x-axis is tangent to the circle. What a great circle. Yep. If and only if, and then some maths. So we know a lot of stuff here, don't we? I suppose we want to know, is this y coordinate down here to make this tangent? Is this y coordinate 1 plus q over 2? Is that equal to the radius of the circle? And the radius of the circle is something you could work out with like Pythagoras, right? Oh my goodness, Pythagoras? Yeah, Pythagoras. Plus, and what is this? Q minus 1 over 2 square rooted. I think I've rushed the Pythagoras there a little bit, but I think that's p over 2 for this side, and I think it's q minus 1 over 2 for the height here, because I'm doing that coordinate take away 1. Yeah, I'm gaining confidence. And then I reckon if you just try and do some squaring, everything works out quite nicely. Is that an overstatement? The q squareds cancel, the quarters cancel, and you're left with, on the left, 2q over 4 from the cross term. On the right, p squared over 4 minus 2q over 4. Okay, so I think it's just p squared equals 4q, which is suspiciously like the discriminant of a quadratic equation with p's and q's in it. MAT PTSD. Sorry, yeah, I didn't really want to do this, right? None of us want to be here. Cool, okay. I think I'm wrapping up. I did that way too fast. It was about distances in the end, and the fact that if you're tangent, then there's a right angle and a radius involved. And we already knew a thing about radii for that circle. Very quick look. F. Geometric series, isn't it? But when does the geometric series, when does it converge? Only if the common ratio is between -1 and 1. or if you prefer the absolute value is like that, which is something like, oh my goodness, when is that small? Quadratics. G we've talked about, H we've somehow talked about, I and J right at the end. Oh gosh, this is transformations of a logarithm graph. Let's not waste any time thinking about this. I think it's too hard and weird, probably. It's supposed to be just transformations of a log graph. If you think about log graphs and transformations, maybe it'll be right. But then it does also say positive solutions, which feels like a lot. Maybe we could do it just by doing something like this to think about solutions. Yeah, it doesn't sound too bad. It's like linear sort of equation, but it's got different cases based on whether these things are positive or negative, whether it works out. Do you get a positive solution? Positive solutions? Big question mark. And then J is one of my favourite sorts of question, which is crazy integrals. Given that this is A, work out the value of that. And it's very tempting just to sort of do 1 over. But actually, these things obey some really nice relationship, which is that if you add them together, that is as if by magic, the top is just x to the -2 multiplied by the bottom, which is like a horrible trick, really, I suppose. Horrible trick's overstating it. Yeah, horrible trick's too much. I take that back. So they add up to half, so it should be half, I say. Does largest refer to magnitude or positive value? I answered that, and then I did a joke about it later. There was a joke about... Oh, never mind. Okay. Did that joke? Where it was a callback. Well, we refer back to the thing, and now it's here again. I think largest means most positive. I agree it's ambiguous, and I will do my best. I guess never to use that word again? That's a too strong a promise, sorry. I'll do my best to look out for that in the future, if I can. Right, good. Okay, I think we've run out of questions, more or less. We've finished on a real downer here. Hopefully the catastrophe is over at some point. If you're doing the additional math on Tuesday, I hope you enjoy it. I hope you get a chance to do some maths without any tech disruption. This time round, if you get tech disruption this time round, then I'm very sorry. But you know the drill now. We're on your side. We want to see the best of you. Let's all hope that we're not all here in 3 weeks' time doing another one. Just got here. I'm so sorry. Timings, because I am now leaving. All the best this weekend. Try and relax a bit. Try and take some time off. I know you weren't planning in your life for very long to do MAT. In our side, we weren't planning for very long to do the MAT from this side. So good luck. Oh no. People are saying MAT 23C in chat. Don't. I think I know I brought that on, but no. Okay. Thanks for the streams. Is it online? So it's going to be many more days than tomorrow in an email on Friday. If I talk for too long, it will become Friday. I'll have to say today. If you're doing it online, you can print it from home or look at it on a screen. If you're doing it in the test center, we're asking the test center to print it. But we are not using the TCS platform for the additional MAT on the 14th of November. Thanks for watching, and I do hope you have a nice evening and get back to doing maths you actually want to do at some point quite soon. Take care. Bye.